definite integral of f of x with respect to x from a to b. That's what we're going to call it, but it means something. There is a one-word answer to this question. What does it actually mean, Alejandro? What does this mean?
Area.
This means area. Now, more specifically, it means bounded area. And, you know, it's been a while, so let's pretend that we've all forgotten. When we say bounded area, it is area that is trapped by four things. There are four parts of the bound. One, the x-axis is one of those four bounds. Miguel, what's another one?
The function.
The function itself. So I'm just going to draw in some function f of x. Last class they got like all hung up on like, but what function is that? It doesn't matter. It's this function. I've got a bound of f of x. I have a bound of x of the x-axis. Jessica, what are the other two bounds? The lower limit and the upper limit. Could not have said it better myself. It's that those vertical lines, x equals a and x equals b, and then we just go find the area, right? Back in the day, how are we finding the area? What are some things that you could do to find this area? Okay, let's stay with the exact area. If I wanted to get the exact area, what could you do? You could go to the calculator, right? And the calculator would do the computations for you. Love that. Sometimes I gave you like a really friendly graph that was made up of like, what, circles and triangles and trapezoids, right? Some of you were even like counting boxes at some point in your life. You're like, well, there's a box, there's a little bit less than a full box, there's a little bit more than a full box. And then we did all that. And then we talked about our friend Riemann. Riemann, the pioneer of mathematics that he was. Without him, there may not actually be a calculus class. So thank goodness for the work that he did. Riemann pioneered 4 different methods for finding this area. I'll take anything from anybody here. What's one of the methods? One of the methods. Fabricio? The trapezoid method was a way. The trapezoid method, he'd like break it up into trapezoids and find the area, and that would get us the exact answer?
Yes.
No, it was an estimate. It was an approximation. So we had the trapezoid method. Josue?
Midpoint method.
The midpoint method was another way. Alejandro?
The right endpoint method.
The right endpoint method. And Abel, let's set the bar low here.
The left endpoint method.
The left endpoint method is the last of the 4. There were these 4 ways to go about estimating definite integrals. We're okay? So then right before winter break, it was like the last thing we did. So I pretty much assume you guys remember nothing. We talked about properties of definite integrals. Right? So this definite integral, this math notation has some properties that makes your life better. Are you okay? You just spun around like you were going to smack Mr. Link. I was worried. Because you might actually do that. One of the properties... Let's see what you guys think. Is this actually a property? Is this true? Have a conversation with somebody near you while I take attendance.
That was involved. A, B, C.
It's the middle.
C is in between A and B.
Sí, del otro lado. Porque lo miré aquí. Acá estaba y lo saqué y se me cayó. $5 cada uno.
All right, let's have the conversation here. If this is a property, it has to work all the time for any function that you can imagine. How many of you would say, yes, this is a property? And you've got some good reason to back this up. Okay, so pretty consistent there. Melissa, how did you come to the decision that this was a property? What did you do? Yeah. You looked in your notes. First of all, that's just the most amazing answer that we could possibly start with. Yes, check. She checked in her notes. An advanced skill. What else could we do? What else could you do for those of you that didn't have your notes? What could you do? Brianna, what could you do?
First, I would look at the definite integral from A to B and would assume those were endpoints.
Okay, but I bet what you did first, you had like some sort of a graph that you looked at?
Yeah.
Okay, so here's f of x. Here's a. Here's b. This guy over here is represented by the definite integral on the left. What's so special about c is that c is somewhere between a and b. This first definite integral says find the area from a to c. Find this guy over here. The next one says now find the definite integral from c to b. That's this guy over here. If I add those two areas together, is it the same as this expression on the left?
Yes.
Always?
Yes.
Always, always, always true. If it's always true, it's a property. In order to say that it fails, how many times does this statement have to fail? Once. If you can come up with one example where it fails, then it's not a property. Yes, sir.
So what if C from C to B it was under? So then when you added it, it was
That's a great question. So when we have area below the x-axis, how does that work? It's been a while. You're going to count it as a negative area if it's below the x-axis. But even if it's a negative area below the x-axis, this would still work. It's a property. It's going to work all the time. What I want to do is take a couple of minutes, and if you want to take out a calculator, feel free. We're going to look at a couple of these statements. And I'm going to say statements, not going to call them properties. It's only a property if this thing works all of the time. And your goal in the next couple minutes is to decide on some of these, whether they are properties or not. So statement number 2 says if f is a continuous even function, then the definite integral from negative a to a of f of x dx is equal to 2 times the definite integral from 0 to a of f of x dx. Can somebody help jog the memories here? Even function. Even function. Even function. Juan, what does it mean to be an even function?
It has an axis of symmetry.
Not an axis of symmetry, a specific axis of symmetry. It's the y-axis, right? You've got y-axis symmetry. And if I asked you guys for some parent function examples of y-axis symmetry, I saw Miguel doing this, right? The parent function there. Oh my God.
Oh, quadratic.
Oh my God. My fingers are straight. The absolute value of x is an example of an even function. Alejandro, another one? Another even function, even parent function. That's why you want to help them out?
Y equals x squared.
Y equals x squared is another fine example of an even function. X squared, absolute value of x. Any other good examples? Y equals cosine of x is another fine example. If you want to go a little more exotic, y equals 1 over x squared. My question for you is this statement always true? If it's always true, give me a graph. Give me some evidence that this is always true. If it's not true, then give me a counterexample. Give me one time where it doesn't work. On the homework? We'll talk later. Is this a property? Does it always work? For any even function that you try, when you pick these limits of integration in the way that they're indicated here, is that always going to work?
Yes.
And the answer is?
Yes.
Yes. Even if I go with some crazy function that I don't know the name of, like if I start sketching the function over here and call that f of x, because it's an even function, I need to have y-axis symmetry. I can draw negative a somewhere over here and positive a somewhere over here. The expression on the left says find the total area from negative a to a. Okay. Is that equal to double the area from 0 to a? Yes, because we have an even function, we have the y-axis symmetry. So you could say that this is, you could say it's true, you could say it's a property, whatever you want to do is fine with me, but it's a property, it's going to be something we can use to make life better. With that said, see what you can do with statement number 4. Statement number 4, don't worry about number 1 yet. Odd function. What are some examples of odd functions? It's been a while. 1 over x is an example of an odd function. X cubed is an example of an odd function. What else? I've already heard x cubed. I've already heard 1 over x. The cubed root of x is another odd function. Another one? Would be sine of x. The sine function is an odd function. Odd functions have what we call rotational symmetry. If I just wanted some generic example, maybe I draw that. Rotational symmetry means I can take this function, I can rotate it around the origin, and so this part over here now would go down over there. No matter where I draw the vertical line x equals a, the vertical line x equals negative a is going to have to be over here. And what do we know about these areas? They're going to have to cancel, right? They're going to have to be, they're equal but opposite, because this guy over here in my graph looks to have a positive area. Because of rotational symmetry, if this has positive area, this guy over here is going to have negative area. So this one is true. See what you can do with statement number 1. This is the last generic property that we'll do before we look at a couple of examples. Last period, Jose was convinced that it was a property because what he said is, oh, it looks to me like the definite integral, right? The word he uses, it said it looks like it was getting distributed, right? That you're saying find the definite integral of f of x, find the definite integral of g of x, and just multiply those together. Now, if it's true, it has to work all the time. What I would encourage you guys to do, if you're not sure about the geometry of what this looks like, and quite honestly, I'm not sure what the geometry looks like either, of the function f of x times g of x, maybe pick a nice function. Right? Pick any function that you want for f of x. Maybe you think, all right, so if f of x is x squared, g of x could be some other function. Maybe it's e to the x. Don't pick these. Okay? These are going to be mine. My test would be, all right, is it true that the integral from, I don't know, 0 to 2 of x squared times e to the x, is that the same as the integral from 0 to 2 of x squared times the integral from 0 to 2 of e to the x? I don't know yet if those are true, but I want to use my calculator to see if it actually is true.
So basically, the integral not being factored out.
I want to know if we can do that. Don't use my function. Don't use my limits of integration. Jasmine. Sandra. Just throwing stuff. Sandra. And suddenly, all of a sudden. You and I need to get together and talk about a plan. Okay. Did anybody find a pair of functions where this works? Hello? Did anybody find a pair of functions where this works? Okay, or let me ask the question this way. Did anybody find a pair of functions and it didn't work? If even one of the 17 of you, Cassandra found an example where this property didn't work. So our conclusion is, this isn't a property. This isn't a thing you can do. So this is false. And there is a lot of disappointment last period because a lot of folks were like, but no, it looks like it should be true. Doesn't it look like I should be able to distribute the integral through? It might look like that, but it actually is not true. You can distribute the definite integral if this was an addition problem. You can distribute over subtraction, but you cannot over multiplication. And usually in the world of mathematics, if something is false for multiplication, it's generally also false for division, because those two go hand in hand. So neither one of those are properties, and I want to be careful about that. All right, so let's look at a couple multiple choice questions. Specifically, we'd start with number one. There's maybe 2 or 3 that I want to see if we can get through. Okay, number 1 says if the definite integral from -5 to 2 is equal to -17, and the definite integral from 5 to 2 is equal to -4, then what's the definite integral from -5 to 5? Have a strategy conversation with somebody near you. What are you going to do? How are you going to start this problem? All right, folks, want to plug it together. What I've seen for most of you, you've drawn some sort of a function, and you said the area from -5 to 2 is -17. Now, let's look at my graph, for example, for a second. How do we feel about this graph? Good. Both ways feeling good about this. Solomon, you're not feeling so good about this. What don't you like about this?
The area is -17
The area from -5 to 2 is -17, so what do you know?
That it's on the bottom of the x-axis.
Now I want to be careful, that's a little strong, because what I heard you say is this whole area has to be like below the x-axis. Does that have to be true? It doesn't have to be true that the whole thing is below the x-axis, but there should be more area below the x-axis than there is above, because we've got an answer of -17 for the area. But for right now, just for the example, let's go with it. There's an area of -17 over here. And then they tell me that the area from 5 to 2 is -4. Well, here's 2, here's 5, that area is -4. Most popular wrong answer? A. Why not A? Why not A, Jessica? What's wrong with A?
You're not adding both of the 17 and 4. You won't add them because it's saying from 2 to 5, and the upper limit is 2 and the lower limit is 5.
The upper limit is 2, the lower limit is 5. So if I'm really going to read this, this says that the area from, not from 2 to 5, but the area from 5 to 2. And one of the things that we talked about a while ago is order matters, right? Direction matters. If the area from 5 to 2 is -4, then the area from 2 to 5 has to be +4. So really what I need to do is I need to say, oh, I've got -17 as this first area, plus an area of 4, and that's going to give me an area of -13. So it should be B. How many guys honestly had B? All right, well, clearing off the cobwebs. All right, number 3, let's see if we can do with this one. We get just enough time. F is an odd function such that the integral from 0 to 4 of f of x dx is equal to 8, and k is a constant. I want to look at this definite integral from -4 to 4 of k times f of x plus 2 dx. There are a couple of nice properties. We haven't talked about them here yet today, but there are some nice things we could do with the definite integral, such as you can distribute this definite integral over addition. So we could say that the definite integral from -4 to 4 of k times f of x plus the definite integral from -4 of 2 with respect to x, that's actually something I can do. I can distribute the integral over addition. One of the other really nice properties has to do with this definite integral over here. There was something really nice you can do.
Does it?
You can factor that's okay.
You can factor out the k. Why? Because it's a constant. You can factor constants out in front of the definite integral. So now you've got k times the definite integral from -4 to 4 of f of x dx plus the definite integral from -4 to 4 of 2 dx. Now what's the area from -4 to 4?
0.
They gave you some information in the problem. I know that the area from 0 to 4 is equal to 8. So the area from -4 to 4 has to be
0.
0, right? Fabricio, why 0?
Because it's an odd function.
Because you've got an odd function. You've got that rotational symmetry. If this had been an even function, what would that total area be? Then this guy over here would be 16. So now I've got k times 0 plus the definite integral from -4 to 4 of 2 with respect to x. One of two things is going to happen here. You either remember the property, or you look at this problem and say, aha, that's something I can type into my calculator. Right on the calculate screen I can say, so let's go find the definite integral from -4 to 4 of 2 dx. You either remember the property, or you don't. Or you type it into the calculator. I bet once you type it into the calculator and get a nice number, you're going to see exactly what you were supposed to remember. The definite integral from -4 to 4 of 2 with respect to x is 16. Why 16? Why 16? The definite integral from -4 to 4 means area. It means area trapped by 4 things. What are the 4 things?
X-axis,
The x-axis. There's my x-axis. What else?
the graph,
The graph, the function. What's the function?
2.
2. It's a horizontal line at y equals 2. Say it with me just for a second. The vertical line x equals -4. The vertical line x equals +4. What I just made was a rectangle. How tall is the rectangle? 2. How wide? 8. What's the area? 16. Right, so k times 0 is 0 plus 16 is 16. So that should be C. Tonight for homework, what I want you guys to do is finish the rest of the multiple choice questions. Do not worry about the open-ended questions on page 2. These are all just going to be